Hello YouTube, this is Frank, and this is December 8th, 2024, and this is my 90th video, my 11th Libre Computer video, and this is 5 out of 8 of the Libre Computer Tritium, making a NTP server with a GPS receiver, and this is number 5, Data Analysis 1. And I'll move my board out of the way and show you what I got. Let's see. I'm going to blow my screen up. Let's see. All right. Disclosure, I have no financial, employment, personal, or family relationship with any brand or product. I purchase products that appear in my videos with my money. I'm retired. I put her around. AI was not used in this video. Videos in this series. This is Data Analysis 1. Note, when Hurricane Helene came through in September 2024, it crashed a time server that I had built, an NTP time server, and I replaced that with a Libre Computer Renegade, and that was in October, and I made 2 more Libre Computer tests with USB receivers, and in December I decided to go ahead and make a YouTube video, and this is what we're doing right here. Now, Hurricane Helene came through Georgia and North Carolina, and that's what crashed that time server. Let me show you now. This is I'll just show you the typical consumer PC. This one that we're working on right now. This is the NIST page, and if we kind of go down, you can see the clock is off by almost 0.4 of a second, and that's typical with consumer PCs. That's fine. I don't have any precision devices here, and this is not a pulse per second video for microsecond accuracy, and that's a microsecond, and just a few tenths of a milliseconds. That's okay for my purposes. I don't have any devices that require that accuracy, microsecond accuracy. The Tritium that I set up on Friday, it does not have enough data for my analysis that I want to do. So I'm going to use another one of my test Tritiums that I set up in November. But now this is what we're doing. If we have an isolated router with several devices, and I want to make a Tritium time server, NTP time server with the GPS receiver. But right now we're connected the Tritium to the internet for setup. And now once we get it set up, we'll hook it up to the isolated router. Summary: if you don't want to watch the rest of this video, I'll tell you what the summary is. We're using peer stats from one of those test Tritiums. The test Tritium, it was started in November. We're going to calculate the statistics manually. We're going to check the math in the NTP Secure project. And I use LibreOffice to do that for my spreadsheet. And I found that the skewness statistic is not calculated correctly in NTPviz, NTP Secure. Kurtosis statistic is not calculated correctly in NTPviz. NTP security. I think you need to, NTP security, I think you need to correct your calculations for skewness and kurtosis. And also, in your table, your summary, I need a count of the observations that you are using in your equations. It would be very helpful if you would print out the N in your summary table. And I want to see the first observation that you used in your calculations, so I can kind of make sure I'm using the same set of observations that you are. So that's for, if anybody at the NTP Security is watching this, this is what I need. And this is what you need to do to correct your security. Now, in the past, I have filed bug reports to major outfits. Now, I'm not going down that path again. I'm not creating an online account to file a bug report. I've been there, done that. I'm not doing that again. Now, I will show you the lines in the NTPviz source in this video, and I will show you how to fix those bugs, but I will not create an account and file a bug report. Okay, now we're going into the details. This is just the rest of the video will just be showing how I found all of this out right here for those equations. So the details. Now, I do not claim any math skills above the community college level, and we'll just use basic introductory statistics. We will calculate the statistics manually and check the math in that NTP Secure project. I'll use LibreOffice. For my private home use, I use LibreOffice. Now, in my opinion, LibreOffice has improved the last few years. Calculations seem much faster. Excel, Microsoft Excel. I have no problem with Microsoft Excel. I used Microsoft Excel at work for years, and they had a site license. But I'm just not going to, for me here at the house, I am not creating an online account for any hardware or software products. That kind of gives, that's software there. So I mean, I'm just not going to create. I'm just done creating personal accounts all over the internet. That's what I'm saying. Now this summary, it's from the NTPviz program. The summary is 7 days for 7 days in November from one of those test tritiums. And let me just show you what I'm talking about here. This is the directory for the that I saved from my NTP test there, and I had a there's my peer stats. I'll just show you what that is. Oops. The peer stats. The day. The seconds, and then there's a server, and then there's the a code, and then an offset, and then some more numbers. And what we're interested in is the SHM. That's the GPS server, Tritium server. And so I filtered out all of those SHM, and let me show you what we got. So here's my file that I'm looking at right now to compare with the NTPviz program. That I've got all the shared memory server pulled out into that file. So what we'll do, I will show you how I check the skewness and kurtosis. We'll open up that peer stats file, go down to the bottom, just put in the descriptive statistics. Column E is what we're looking at, and check our calculations versus NTP. So let me just show you. Oops, let me get our spreadsheet. Calc. And let's see here, we need to open that file. And see, there's that file I was talking about right there. It has the, and we'll just do separated by spaces. Okay, here's our file. So we go down to the bottom, just go down a few rows, and I will it's data, statistics, descriptive statistics, and our column E, that's the one that has the offsets in. That's the one we're going to do. And let me see here now. Go to the top. Okay. And go down to the bottom. And this is where we'll put the descriptive statistics, and we'll widen that row or column. All right. Now, let me get back to my notes because I think there's something I want to mention. Notice in that table, the first observation. Let me show you what I'm talking about right here. Let's get back over there. See that right there, that first number right there? That's the first observation that they're using. So let me just show you what I'm talking about. If we go over here to that column right there, copy it. See right there? That's the first observation there that they're starting with. So see now, if I know the first observation and the count of those observations, I can kind of make sure I'm using the same set of observations that NTPviz is. And that's what I'm ranting about is I need to see the count and that first observation so I can make sure. But anyway, okay, let's show you my what we got over here. Okay, here's my statistics that I ran for a 7-day period back in November. And if we kind of go down here to near the bottom of the file, they've got a summary table. Now, since I'm retired, I've got plenty of time to check the statistics, and that's what I did. So here is our server, SHM, and this is the line that we need to be checking. See this one right here? Now I want you to notice, well, let me just check just a couple more. The standard deviation, here's the standard deviation. Let's just check it before I get started on my rant. Standard deviation, 53507, and that checks out. Oops. Let me get back over to my 5.307. Now let's check the mean. 54.810. 54. The mean 54.810. That's close enough. Okay, now I'm going to start my rant here. We need to check the skewness. Oops. Okay, you see that number right there? Negative 1488. 1,488. Now let's get over here to my descriptive statistics. Do you see that right there? That's a negative 0.8. And I was looking at that, and I was wondering, how can they be so different? Now look at the kurtosis. That's what, 17,000. So let's get over here to our descriptives. And kurtosis, they've got 65. And I saw that, and I was just wondering, that don't look right to me. Now, I'm a dum-dum. I only have community college statistics, but that don't look right to me. So anyway, I made this is a copy of that table so we can look at it in my notes right here. And I made the table. See, this is what I'm seeing. I'm seeing the negative 0.8, and they've got negative 1,400. Kurtosis, they got 65, and they got, look, 17,000. So yeah, why is the skewness and the kurtosis so different? So yeah, let's put my community college statistics into introductory statistics into use right here, and let's just show the NIST measures of skewness and kurtosis. I've got a page right here. Let me see. There it is right here. NIST Engineering Statistics Handbook, measures of skewness and kurtosis. And there's our equation for skewness. It's just the observations minus the mean cubed, divide that by n, and divide that by the standard deviation cubed. So we can do that. That's not very hard. And what I'll do is set this up. Just get our observations. I'll just make a copy, just to make sure we're looking at the copy. And paste special. And I'm going to paste, I'm going to paste number. All right. Now, I believe that we need standard deviation, mean, and count right there. So in my notes right here, I think I got it. Yeah, we'll just drop down a few columns: mean, standard deviation, and the count. And we have our observations are in column K. So it's mean, standard deviation, and the n. The mean is just the average, and we'll just take the average of this. The standard deviation, the count, count. All right. Now that's what we need for that equation. All right, we'll see if we can calculate. Well, let's see. We need to we need to sum those observations minus the mean cubed, and we could do that. Okay, that's the observation minus the mean and we need to cube this. Cube. All right, copy. And paste. And we need a sum. Let's see now. A sum. We need the. I'm just going to put the sum over here. We use that function quite a bit, and it's just the sum of all right. There's our sum. And now we can calculate that NIST. And it's 1 over standard of the count, 1 over the count times standard deviation cubed times that sum all right, and see, this is what NIST was saying, and now look at our skewness over here. See, we're just about it right there. Now, LibreOffice, they use a slightly different equation. So let's just see what they use. The LibreOffice. Now I've got their web page up right here to calculate the skewness, and they've got an equation that they use. Now see all these ends right here. It would be very helpful if NTP had those ends on their summary table. But anyway, that's my plan. It's n divided by n minus 1 times n minus 2, and that's their adjusted n. And I think I've got it in my notes right here. That's the NIST skewness. We calculated that, and it was kind of close. So we're going to adjust the n and calculate it the way LibreOffice and Microsoft Excel calculate the skewness, and it's just the adjusted n times that 1 over standard deviation cubed times the sum, and we'll see what we get. Now, just to bring that into your attention, LibreOffice and Microsoft Excel, they use the same equation for skewness. So we need that adjusted n. The skewness adjusted n, and that was n divided by n minus 1, n minus 2. N divided by n minus 1 n minus 2. Okay, that's our adjusted n, and I'm going to come down here. Now this is our skewness. I'll put it kind of on the same line because we're going to be over there. Just make sure we're on the same line here. That was the adjusted n times 1 over standard deviation cubed times the sum. All right, see this right here? Now we get the same skewness there, and that's how we calculated. That's how I would calculate skewness, and I'm going to highlight that. Now this is the correct skewness. Now let's see. Now let's see. How is skewness calculated in NTP? Well, we need to go to their web page, go to downloads, go to their source code, and then go to their Python. And we'll do that right here. Look, first let me just show the license, just in case anybody is wondering here. This is the license, BSD clause 2, the NTP license, permission to use, copy, modify, distribute, BSD clause, or permission to do all that. So I just wanted to get the kind of the legal stuff out of the way here before I go to their source code. So it's go to their main page, downloads. There's their source code. Go to their source code, NTP secure, and then we need to go down to the NTP clients, and we need to kind of go down to the bottom. There's the NTPviz. See, this is the December the 8th. When I'm making this video, and last change was made, and this one was 11 months ago. I don't know how long this has been in this program. So if we kind of go down here, and let's just see where the statistics are calculated. Go down just a little bit. Here we go. See, their number of samples. Mu is their arithmetic mean. Variance. Sigma is the standard deviation, and then skewness, kurtosis. So they're just there's the mean is the average. Standard deviation just the square root of the variance. So that's just kind of that's now. This is how they're doing skewness. Is they set their sum to 0, and it's, look at what they're doing. Value minus standard deviation. Sigma is standard deviation. See right here? Standard deviation. And they're raising that to the third. And then they doing that, the sum divided by the n times standard deviation to the third. So let's just do what they do. Okay. And this is the observation minus the standard deviation makes, see right here, that's standard deviation. That's what they got in their code. And we raise that to the third power. We got it. And paste. And we'll need to, let's see, we need that sum. I'll copy and paste. Okay, there's our sum. And let's just go down here. Okay, this is the and in their equation they've got the sum divided by n times standard deviation cubed. It's the sum divided by n times standard deviation cubed. Now, what you think that's going to be? 1488. Yep, that's that. That's, look at that right there. Let me highlight that right there. NTP. What's going on with your calculation here? Wonder if anybody has checked that in years. All right, so there's our skewness there. I think, I mean, it's off by what, 1, 2, 3, 4, 5, 4 orders of magnitude. So let me get back to my notes. Yeah, see, they're using standard deviation, and that's tell you what line number it is. It's line number 198 right there. See, 198. They need to change that standard deviation to the mean. All right, let me see now. That's the correct way to do it right there. Now kurtosis. Now, LibreOffice and Microsoft Excel, they compute excess kurtosis. And just a heads up, positive kurtosis is a heavy tail, negative kurtosis is a light tail. And NTPsec, they don't do the excess kurtosis. So let me show you what we're talking about here. Let me go to the web page right here. This is the NIST. Down here to the kurtosis. There's the formula. There's the equation for kurtosis, and it's just nearly the same there as the skewness, except it's just raised to the fourth power. And we can do that. Let me just tell you this. The kurtosis for a normal standard distribution is 3. And this is where that excess kurtosis is what we're talking about. You just subtract 3 to kind of make it 0, the kurtosis of 0, and then that way your positive kurtosis is heavy tail, and then your negative kurtosis is light tail. So I just wanted to kind of bring that to your attention. So we'll do the NIST kurtosis, and I'm going to come over a different column over here. Let me kind of scoot over a little bit, and that was our observation minus the mean. That's this mean right there. And we want to raise that to the fourth power. And paste it. And we need that sum. Copy that sum. There's our sum. Now we should be able to, for NIST, we should be able to calculate that kurtosis. And it was, 1 over n times standard deviation to the fourth power. Standard deviation to the fourth power. Times that sum. Now I wonder what we get here. See, 68. That's kind of, I got to move my spreadsheet over here. See, kurtosis, see 65, and they got 68 right there. And this is that excess kurtosis is what they're talking about. If we just subtract 3 from that, 3 minus, and that's the excess kurtosis. And see, you can see it's very close to our kurtosis over here. See right there, 65.78. That's 65.77 right there. But let's okay. I'm on. This is my kurtosis, and so let's calculate the way LibreOffice does. Now, I've got my web page for LibreOffice, and this is the way they calculate kurtosis. Let's kind of go down here. Now, see, that tells you right there. See, sample. It returns the sample excess kurtosis. So down here where they have their equation, so they got an adjusted in, and then they've got that adjusted 3 right there. So we'll see if we can put our adjusted in and adjusted 3 in our spreadsheet. And I'm going to call that K adjusted. K adjusted in. And that was n times n plus 1 divided by n minus 1 times, oops, let me close my parentheses right there, times n minus 2 times n minus 3. Now it should be close to our, see, it's kind of close to that adjusted in right there. This is a little bit different. And now we got to have that adjusted kurtosis adjusted 3. And let me see here. That was what was that now? 3 times n minus 1 squared divided by n minus 2, n minus 3. All right, we can do that. It's 3 times n minus 1, oops, n, the number, minus 1 squared divided by n minus 2. Oops, let me put that, I got to put the number in, not the letter. N minus 2 times n minus 3. And that should be close to 3. Yes, it's real close to 3. And we should be able to calculate our kurtosis. I'm going to put this on line there so that we can see that kurtosis. It says right here, we're going to keep the kurtosis on the same line. So that's our adjusted n times 1 over standard deviation cubed to the fourth times our sum, and then we're minus the adjusted 3. All right, now see this right here? We get the same kurtosis right there. I'm going to call that correct. See kurtosis? That's the excess kurtosis. So let's highlight that. That's our correct excess. Correct excess. Now, you know, if we look at the way, let me get to my notes just to make sure. Okay, so we did, we calculated NIST kurtosis. Well, now we calculated LibreOffice kurtosis. There's that adjusted in. There's the adjusted 3. There's the adjusted in. 1 over 7. And then minus the adjusted 3. So we just did that. And we get, we know how kurtosis is calculated. So how is kurtosis calculated in NTP? Well, let's see now. We just go over there to the source code and look. And it's on line 199. So we get over there. So, now he does have a default there, so he is not doing excess kurtosis. He's doing that 3. So it's value minus sigma. So look at there. That's sigma is standard deviation. I believe that should be mean. So anyway, let's do it the way he does. It's observation minus the standard deviation to the 4th power. Copy. Paste. And we need that sum. Copy. Paste. And let's see if we can get the same results. Let's see now. It's over here in this code. See, you got the M4, the sum, divided by n times standard deviation to the 4th. It was the sum divided by n times standard deviation to the 4th. Now what you think that's going to come out to be? There it is. And NTP, what's going on here now? Has anybody ever looked at that? I wonder in the last 10 years. That's very different. See, look at here at our kurtosis. That's what, 1, 2, 3, 3 orders of magnitude off of there. Here's our table. See, there's that 1.7 to the times e to the 10 to the 4th. And that's what we got over here. So I think the NTP is kind of, I'm not sure they're calculating that correctly. From what I can tell, they're not calculating that correctly. Now, if it was me and I see this right here, I'm checking every value in this table. And so let's do that then. Check every value in this row anyway. See this row right here? We'll check every value in it. And the percentiles, that's what we'll do. Check the percentiles. That's really easy right here. We get our observations. Here's our observations. Copy. And oops. And let's just kind of go down to we had our observations in that column. Let's just kind of go down to put our comment, and I'll paste that special number. All right. And oops, dang, I should have sorted it first. We need to sort that. We need to, let me go down. We need to sort that because we're doing percentiles right here. All right, there we go. Now we just need the number 1. And it's sheet, fill cells with the series and the number. Okay, now we can do our percent. And that's percent should be pretty easy. It's what the number divided by the count There's our count right here. Times 100. And we need to copy. Oops, copy. Let's see if I can get down this row right here. And paste. All right. So there's our percentage. There's our the minimum. Let's just check the minimum while we're here. 184.822. 184.82. Okay, that rounds up. Okay, that's okay. The next one is the 1%. We get down to the 1%. There it is down here. 63.146. 1%, 63.146 right there. See that one right there? Let me get back to my notes just to. That's what we did. Compute the same percentile. Now let's check the 5%. And we just need to go down to 5%. 2, 3, 4, 5. Okay, 60.619. 5%. 60.619. Is that okay? What do we got here? 60.169. See that rounds up to 60.20. If I'm looking at that correctly, I kind of think it would be that one. So I would, let me just highlight that one because if they would, that's why I need to know the end and the starting observation to check all of my work against theirs. All right, so let's just go down to the 50%. 50%. 50%. I'm gonna have to scroll fast down there. Oops, went past it. There it is. 55.253. 55.253. Okay, there it is. Okay, that one seems to be okay. All right, the next one, let's just go down to the bottom and work our way back up. So this will be the max, 2.779. 2.779. The next one, 99%, 40.723. 99%. Let's get back up here to 99. There it is. 40.727. What? Let's see now. 99%. I'm not sure that one's right either. See, right here, the next one down is 40.723. Let me highlight that one right there. Because I don't think that one is. So I got my question mark right there. Let's look at the 95%. There's 96, 95. Oops, here we go. 95. 48.391. What have they got in the table over here? Well, 48.388. See, that looks like it right there. Let me highlight that one. So, so that's what I kind of, once I saw the kurtosis, the errors in the kurtosis, and I thought I'd better check every value in that table. So if anybody on NTP Network Time Protocol is watching this video, I might want to check out your source code there. Okay, now that's my analysis. They appear to be incorrect. We need an N in your table so I can make sure we get the right count. And I also would like to see a line of the first observations so I can make sure I'm looking at the same observations as you are. And that's the end of my video. Thank you for watching. Let's see if I can turn it off.